Okay, guys, today we're looking at section 6.4, where we're going to start to explore the transformations of your sine curve. So far you know what a periodic function is, and you should have realized yesterday that sine and cos both produce periodic functions, and we're going to take those functions, we're going to start to graph them today. So go back to chapter 1. Hopefully this equation here looks familiar. So any function can be described by a set of transformations, right? The C value will take your function and move it up or down. The D value will translate it or shift it left and right. The A value is the vertical stretch or compression. It is also a reflection through the x-axis, which means an up and down reflection. The K value is a left and right reflection or a horizontal reflection through the y-axis, as well as a compression or stretch. Keep in mind, anything inside the function brackets, the signs, or I guess they're opposite in quotes. So even though this says minus d, if it happens to be x minus 2, because of the subtraction sign, it would actually be a rightward direction. And then the k value, if it's a positive 2, would mean a horizontal compression. Okay, so inside the brackets is backwards. Just keep that in mind. We spoke about that in chapter 1. Okay, so you have a graph. Assume that you have a graph of y equals sine theta plus a number. It should be related to plain old sine of theta, except there's a vertical translation or a vertical shift. Okay, it means it's moving up or down. And then the displacement, the movement, would be your actual q value, just like chapter 1. The same is true for anything with cos or with tan. So let's jump right in. Let's take a quick look at what this guy would be here. So this is your basic sine theta. So if you took your main kind of few points from sine, we realized yesterday we had a point at 0, 0. Now it's really hard for me to see there. But at 30 degrees, it should have been 0.5, which I believe is there. At 60, it should have been 0.8, which should be a little bit higher. 90 should have been 1. And then 0.866, 0.5, 0, and then you start going into the negative versions. Okay, there, that should be -1 at 270. Let's just do our big points. There we go. I'm doing all of them. You don't have to. You can go 0, 1, 0, -1, and 0. Okay, just get those guys. And you should see, I'm just going to leave my dots here. You should see kind of a pretty curve. It is a periodic function. It's got a cycle that would repeat. So this is our basic sine curve. Now, this plus 2 means that I have to take my curve and shift it up 2 units. Nothing else changes with it. So I'm going to use a different pen here so we can see, or different color. Let's go in red. And each one of these is going to be moved up 2 units. So it's like I've taken my x-axis and moved it up to y equals 2. And I'm just going to use my big points this time. So it's like I've got an imaginary line. Let's draw a beautiful thin line here. Let's go in blue, I suppose. Okay, and at 2, there we go. So I've shifted it up 2 units. I've taken this x-axis and moved it up. And now I'm going to use my pen tool to draw in the best curve that I can. And again, I'm just going to use my main points. So 0, 0, 90, 1, 180, 0, 270, -1, and 360, +1. Okay, so all I've done is I've taken these and I've counted them up 1, 2 units. Oops, sorry, that helps when I put it in the right spot. And I've moved it up 1, 2 units. Okay, see this one, 1, 2, 1, 2, 1, 2. So they all go up by 2 units. You can then, now that you've got your main points, draw a very nice sine curve. Do not give me straight lines. They are not straight lines. They are curves, and you know that. Okay, so there's my beautiful sine curve. Answer a few questions at the side just to make sure you've got an idea of what's happening with your curve. So the vertical displacement. My graph was shifted up 2 units from the original sine. So this is up 2. Okay, shift up 2 units. My amplitude. Well, my amplitude is still from my new equation here, up a whole 1 unit. It hasn't been stretched or compressed at all. So my amplitude is still 1. The period of the function goes across 360 degrees before it repeats. We haven't stretched or compressed this vertically yet, so it's still 360 degrees. My maximum Y value, okay, well that's 2. My maximum point happened at 3, and my minimum happened this time at +1, right? It was -1, but it went up 2 units. So I've taken my basic sine function and I've just moved it up 2, okay? All right, take a look at a cosine function. Here is your basic cosine. This one has been moved down 4, right? Subtract 4 would mean down. So let's get our basic cosine function. So remember, cosine doesn't start at 0. That would be, the cosine is your x values. And on a unit circle, it would have an x value of 1, right? Because the terminal arm would reach out a unit length of 1. So this one starts at 1, and then it starts to go down. Now I'm going to use, again, my main points. So 1 at 90 degrees at 0. At 180, it should be -1. At 270, it's 0. And at 360, it's +1. You should have these points memorized. Okay? Again, do not draw me straight lines. This is not a straight line. If you were to put the other values in here, there, it's kind of the reverse to the sine. Okay, and if you don't believe that I've got the right points, then you can go look them up. Okay, all right, so there's my curve. This is my graph, so that's basic cosine. My current function should have been shifted down 4 units. So I'm going to take these and I'm going to actually move them down 4 units. Now, each one of my grid points has a scale of 0.5, so to go down a single unit, I have to go down 2 squares. So this is, oh, let's go ahead, sorry, different marker. Tools, pen, we'll go red again. So 1, 2, 3, 4. Okay, this will be where my new equation of the axis would be. So again, I'm going to draw a new one in here. We'll go blue again, make it nice and thin so you can see it. Okay. And really what I'm doing is I'm taking each one of these and I'm translating them or shifting them down 4 units. So 1, 2, 3, and this one doesn't quite fit. I don't think I went far enough on it. Should be down there. And you can translate all of them. So I'm going to use my little cheap trick. Oops, actually I counted too far. I'm going to use my cheap trick, and there's my new equation of the axis. 1, 2, 3. Oh, you know what? I just made a mistake. There it is, right? If my equation of the axis is here, it would have been moved down 4 points. So each one of these dots, each one of these black dots, part of my cosine curve would be moved down 4 units. There we go. So this one, 1, 2, 3, 4. This guy, 1, 2, 3, oops, 4. It should be right here a little bit. Again, I'm going to start using just my main points, otherwise we will be taking too long. So this is 1, 2, 3, 4. This one I've already moved. This one 4 units down would be there, and this guy 4 units down should be there. Okay, and you should see a nice curve. That would be your cosine law, or your cosine function graphed. This one does look a little bit funnier. It's just from a peak to the next peak, okay? So it's like the sine law, sine function, but just you're going from peak to peak instead of from a middle point to a middle point. Okay, so let's take a look over here. Our vertical displacement, we know that this one was shifted down 4 units. Oops. So this is down 4. My amplitude, again, the amplitude is from the equation of the axis to the highest point. Again, we are still going up 1. If you wanted to use your equation, my new high point is at -3 and my new low point is at -5. So if I take -3, subtract -5, That would give me positive 2. Positive 2 divided by 2 is 1. That matches our amplitude. Okay, the period is the distance of your cycle. So we are going from 0 to 360 degrees because it has not been stretched or compressed at all. My maximum value is -3 and my minimum is -5. Okay, so graph your points, the values added after the theta, not included with theta on the outside, will either shift up or shift down. Okay, that goes straight back to chapter 1. All right, but that's not all, but wait, there's more. We can also have, there we go. In addition to our shift going left, up and down, we can also have phase shifts that go left and right. Sorry, I just noticed another mistake. So we have now our vertical shifts that we know about. We can also have our horizontal ones. These are your negative and positive phase shifts, which would go to the left and the right. A negative phase shift goes to the left. A positive phase shift or positive translation goes to the right. Keep in mind, though, in here, because there's a subtraction sign, just like your regular function, if I were to put a negative sign in here, this, or a negative number, this would become a plus sign. So it's a negative value, which means it goes to the left, even though you might see a plus sign, just like the other functions from chapter 1. So if there is a value inside a set of brackets with your angle, so it affects your angle, this brings it a shift left and right. Okay, and the same is true for both sine, cos and tan. Okay, I'm just going to do this one example. Oh no, never mind. I'm going to do all of them. I'm going to do this example with you. You can look in your textbook for other examples. So we are going to draw cos of theta. We're going to try and draw it over 2 cycles if we can fit them in. So the first thing that you need to do is draw plain old cos theta. Cos theta starts at 1, and then at 90 is 0, at 180 is -1. At 270 is 0, and at 360 is +1. Okay. Again, if you are comfortable with your other points, which I would like you to be at some point, please put them in. If you're not comfortable with them, you need to practice more. Okay. So there is your cosine curve. Again, I'm just going to put the dots in here, and you can connect with the other one. So these dots now have a phase shift of a p value of +240, which means this is really a -240. So this is going to be left 240 degrees or 240 units. Our amplitude is not going to change. Our amplitude would be from here to here. So our amplitude is still 1. When I graph it, our period, again, it's just shifting it. It's not stretching or compressing. So the period would still be 360 degrees. Our maximum would be +1. Our minimum would be -1. Okay, and I know that this is asking for a transformed graph, but because it's just a shift left and right, it's not compressed or stretched at all. So none of those would change. All right, so let's now take each one of these graphs and let's shift them 240 degrees to the left. So at 0, I need to go down to -240. So this point is going to be all the way over here. Okay, this point at 360, I have to move over or move to the left 240 degrees. So 360 minus 240 is 120. Okay, and I'm just going to move my main points. 180 minus 240 should be -60. 90 minus 240, oops, should be right there at 150. And 270 minus 240 should be 30. Okay. And again, I'm going to put all my other extra points in because I know where they go. It's just to make my graph look a little bit neater and nicer. But as long as you've got the main points in and you realize you're not going to get a straight line, you should be fine. Okay, so this is 1 cycle. Okay, I should connect my dots here, but it does ask for 2 cycles. So now I'm just going to continue. Now that I've got my 1 cycle, I'm going to continue the pattern for the rest. And yes, maybe we'll just put in our main points first. Actually, you know what? I seem to count when I do it. There you go. And there's my second one. So I've just focused really on my main points. There's the positive one, the 0, the negative one, the 0, and the positive one. And I go over 30 degrees every time because that's what we went up by. Okay. All right. And there is my cosine curve of 2 cycles that has been translated to the left 240 degrees. Okay. Last part, this is just coming up with an equation, so it will require a little bit of thought here. When you're coming up with your equations, because you're looking at both sine and cos, you could come up with, there's more than one answer because it's periodic and because you've got 2 functions that produce something very similar. So there are multiple answers here. So if you don't get the same answer I do, that's absolutely fine. So first thing I should do is identify my cycle. So let's start at this one right here. No, actually, let's start at this one. Ooh, I got so many to pick from. I'm going to start at 120, and I notice it goes up and down and up. And the reason I want that is because my sine curve starts at 120. Starts at 0. My sine curve starts at 0, 0. So basically, I'm taking my original sine graph and I'm looking for a point that I can compare it to. So it looks like my sine curve has been moved to the right 120 degrees. So if I'm looking at my sine curve, oops, let's make this, there we go. So f of x equals, right, it could be y equals, but we're going to use our function. Now, I want to put sine of theta or sine of x, but it's been moved to the right, which means that my angle is the one that's being affected. Because it's inside the brackets, the sign would be backwards, so I'm actually going to put minus 120 because it's been moved to the right, okay? And that would be one possible equation to produce this function. If I wanted to produce an equation for the function but using the cosine one, remember cosine starts up high, it starts at 1, and then starts to go down after that. So here would be the beginning of my cosine curve. I could also start it here, but since I can see my cycle, I'm going to start up here. So this one here, if I look, it's at minus 150. So basically, if I wanted to use my cosine, f of x equals cos of, now instead of just x, because it has been shifted to the left 150 degrees, I'm going to put in plus 150 degrees because anything inside the brackets would be backwards. Okay, and that is pretty much it. So there are multiple answers here. These are just 2 possible equations you could get. You have your choice. If your answer doesn't quite match the back of the book, do a quick graph of it to make sure that your graph at least matches, and then you know that you're okay. All right. That's pretty much it. So have fun curve sketching your left and right transformations or your up and down transformations of your sine functions.